Hello, my dear students. I hope you are all doing well. So, my name is Benatang Paton, and I welcome you to the channel Classroom, where we learn together. It's been a lot of time, since the last video was uploaded. But here I am, and then we have a new topic to start. So today we'll be starting chapter 12. The name of the chapter is Magnetic Effects of Electric Current. So let's not waste time. Let's not waste any time, because every moment is important. So lest we get late, and then less I delay you, because I've already delayed you by so many days. So let me not delay you anymore. And so let me quickly start the topic. Let us quickly jump to the lesson and learn together. So let us start a lesson. Now, you know the drill, which is grab your pen, pencil, and a notebook, and then take down the notes, because these notes are going to be very much useful to you. So the first thing that we will ask, the first thing that we will be asking ourselves before we go into this lesson is, since the name of the lesson is Magnetic Effects of Electric Current, let us define what a magnet is. So let's define what is a magnet. So question, what is a magnet? What is a magnet? This is the question that I will ask you. So anyone who can tell me what is a magnet? Yes, I want answers. Who can tell me what is a magnet? Try defining what is a magnet. What is a magnet? The answer to what is a magnet is, what is a magnet, my dear students? A magnet is a substance. A magnet is a substance which can attract pieces of metal, steel, etc. towards itself. This is the definition of what a magnet is. A magnet is a substance which can attract pieces of metal, steel, etc. towards itself. This is what a magnet is. Next, magnets are of different shapes. So let us have a look at the different shapes of magnet. Now, my dear students, today's class is going to be an introduction class only. So we will be discussing topics which you already know. Topics like what a magnet is, and magnetic field and magnetic field lines. These are basics which you have already studied in your lower grades like class 7 and class 8. So it's going to be like a revision for you. So this is going to be very easy, but at the same time, this is very crucial because it will help you develop a strong grip over the preceding topics where you need the knowledge of this point. So magnets are of different shapes. What are the different shapes of magnet? We have bar magnet. It's called a bar magnet because it resembles the chocolate bar. Chocolate like Kit Kat, Munch and all that, they come in bars, isn't it? So bar magnet. So let us draw a bar magnet. A bar magnet will look like a chocolate bar. So every magnet has got two poles. So we have let's draw the north here and let's draw the south here. So this is how a bar magnet look like. And this kind of magnet you will find in your science laboratories. Bar magnet is usually found in science laboratories. For scientific experiments, we use bar magnet. Next one, we have the horseshoe magnet. Horseshoe magnet. So horseshoe magnet, it looks like the letter U. So this particular shape resembles the shoe which is worn by a horse, to help the horse run better, and also to prevent the hoof of the horse from injury. Horses are made to wear metallic shoes which resembles this shape, because the hoofs of the horse is in this shape, is not? So the name horseshoe is given because it resembles the shoe worn by the horses. Okay, so same thing, one side is south, north, and this side is south. This is the shape of a horseshoe magnet. Then we have magnetic needle. We have got magnetic needle. So the shape of a magnetic needle will be like this. Okay, so one end will be colored, which will resemble the north. So this is a magnetic needle. And we also have magnetic compass. So magnetic compass, C-O-M-P-A-S-S. So a magnetic compass, okay, it will have the cardinal points north, we have the east, we have the west, and we have the south. And present inside this, you will have a needle. So this is how a magnetic compass looks like. And this is mostly used by sailors to find directions. Okay, it helps the sailor navigate from in the vast ocean where one can easily get lost. So these are the different shapes, okay, different shapes of magnet. So let me erase this and go to keep it here. So let me erase this and then let's continue to the next topic. The next topic will be properties of magnet. Like I said, it's a revision only. You already know these things. So let it serve as a revision class. Properties of magnets. Very important and very easy also. Point number 1. Magnets always. What is the spelling of always? A-L-W-A-Y-S. My spellings are very weak. I always get confused with spellings. Always exist as dipoles. Well, I was not like this. Okay, I was very good with spellings, but then I'm growing old now, so my the alphabets are running away from me. I wonder what's gonna happen to me if this continues. Okay, scary, isn't it? Very scary. I'm super scared. So magnets always exist as dipole. What is the meaning of this, my dear students? So who can tell me the meaning of the word dipole? Yes, someone? Yes, dipole means having two poles. Okay, di means two. Very good. Di means two. And what are poles? Okay, the two ends of a magnet. Okay, the two ends of a magnet are called poles. So every magnet has got two ends. Okay, so you know that this is how a bar magnet is. And then we have got two ends, isn't it? One end is this, the other end is this one. These are called poles. Okay, the ends of the magnet are called as poles. A magnet has got two poles. One end is the north and the other one is the south. This is the meaning of magnets always exist as dipoles. Okay, remember, magnets cannot be monopole. That means magnets cannot have one pole alone. It will always have two poles. Point number 2. What is point number 2? When a magnet is freely suspended, S-U-S-P-E-N-D-E-D, suspended, it always aligns in north-south direction. Another very important and very interesting point. So when a magnet is freely suspended, it always aligns in north-south direction. For example, let's take a thread and let's say this is the magnet and then it's tied. Then this is the north, this is the south. So on tying a magnet with a thread, this is the thread or a string, So a magnet is being tied and suspended by a thread. So how will the magnet align? The magnet will always align in north-south direction. Alright, for example, let's assume that this marker is the magnet, and let's say there is a string here by which the magnet is tied, and then it's left like that, okay, suspended in mid-air. Okay, then this magnet will align itself in the north-south direction. So let me tell you the orientation of the room that I'm in. The whiteboard that you see behind me, this whiteboard, okay, from your perspective, this is the north, okay, or I should say from my perspective, okay. So this is my north, and I'm looking into the camera placed in front of me. So when I'm looking at you, from my perspective, you are in my south, okay. And then this side is the east, this side is the west. So if I freely suspend a magnet in this room, say for example here, then the magnet will align in the north-south direction. It will never align in east-west direction. Remember this, okay? It will only align in north-south direction. Now, why so? It is so. Okay, very important question. Why so? Why so? Why will the magnet only align in north-south direction? It is because this magnet is interacting with a giant, very big magnet. So this magnet is interacting with a very big magnet. Does anyone know which magnet am I talking about? A very big magnet, okay? A very big magnet of a big scale. Which magnet am I talking about? Yes, where I'm talking about the Earth. Our Earth is a giant, huge magnet. So remember, my dear students, the Earth on which this building is built upon, the Earth on which the trees are growing, the Earth on which we live, is actually a big magnet. Okay, which part of the Earth is magnetic? The core, the innermost part of the core. Okay, the innermost part of the core. The innermost part of the core is magnetic. So you know that our Earth is made up of different layers. We have the crust, which is the thinnest layer. Then we have the mantle, and we have the core. So this is the core. Okay, the core, the innermost layer. The core is the innermost layer. So C-O-R-E, core, and this is the mantle, and this is the crust. The thinnest layer of all is the crust. Okay, we are living on the crust. Okay, then between the crust, just below the crust, you have the mantle. Okay, and innermost layer of the Earth is the core. Okay, the core is in molten state. This is in molten state. Molten state. Okay, molten state is a liquid state. Okay, a liquid state achieved because of tremendously high temperature. Okay, it's called a molten state. Okay, so the core is in molten state and it carries charges. There are charges present in the core. So the presence of excuse me excuse me, the presence of charges in the core. Okay, so the presence of charges in the core, okay, makes it magnetic. So it is the presence of charges in the core which gives the magnetic nature to the core, thereby making the Earth a big giant magnet. So I hope it is clear. Okay, next, point number 3. So what is point number 3? Like poles repel, whereas unlike poles attract. So like poles repel. What is the meaning of like poles? Means same pole, north north, south south. Unlike pole means north south, whereas unlike poles attract. So like poles, so a north, this also north, south, south. So see, north north, the north side, the north face of one magnet facing the north side of the other magnet. So like poles they are facing each other. So here what will they experience? They will experience repulsion. Here a force of repulsion will be experienced. Similarly, the same goes for this. If I bring the south and the south, again there will be repulsion. Okay, you already know this. Like I said, today's topic is all simple revision only. Okay, north, south, but this time let's make opposite poles face each other. Then what will happen? There will be strong force of attraction between the two poles, because the poles are opposite. Okay, whereas the poles here are like poles, they are of the same. Okay, they are same poles only. Next point number 4. Two poles can never be separated. This is also very important. Okay, two poles can never be separated. What does it mean? It means to say that let's take this, let's say this is the north and let's say this is the south. Okay, now using a cutting tool, let me split this magnet into two parts. So let me split from this part. Okay, from this part. So I have managed to cut the magnet into two parts, and these are the two parts. Okay, so I cut this magnet, okay, because I wanted to separate the south and north, because it was marked on the magnet, bar magnet. Okay, this part. Okay, and then this mark was present here, indicating that all of this part is the south and all of this part, okay, is the north. So I did cut at this mark, okay, because I wanted to separate the north from the magnet and the south from the magnet. So I cut it in the exact I cut it here exactly on this mark, and I've managed to separate. Okay, now, so does it mean that now all of this is south and all of this is north? So have I managed to separate the south, okay, from the north and the north from the south? No. Okay, this is impossible. I can never separate, okay, south and north from a magnet. I cannot separate. It's written very clearly here. Two poles can never be separated. That means we can never separate the two poles. So the moment I split it like that, what will happen? A corresponding knot will be developed here, and on this part of the magnet, a corresponding south will be developed. So this is what happens when you break a magnet into two parts or three parts. No matter how many parts you break it, every single piece of the broken pieces will have two poles. Okay, it will develop its own corresponding poles. Okay, so don't expect that, or don't think that you can separate the two poles from a bar magnet. It is impossible. So my dear students, these are the properties of magnet. Okay, now I will erase this and we'll discuss the next topic, which is magnetic field and magnetic field lines. So quickly, let me erase this and let us discuss the next topic. The next topic is magnetic field and magnetic field lines. So magnetic field and magnetic field lines. So what is the meaning of magnetic field and what do you mean by magnetic field lines? By magnetic field, we are talking about the region surrounding the magnet whereby its influence can be felt. Let's write it down. Magnetic field. Magnetic field. Definition: the region surrounding the magnet the region surrounding the magnet whereby its influence here means its magnetism, okay, where its force of attraction or repulsion. So where its influence can be felt is known as magnetic field. Next, the field exists in the form of lines and is known as magnetic field lines. Very important. So the region surrounding the magnet whereby its influence can be felt is known as magnetic field. So the region surrounding a magnet, imagine this is the magnet, and the region surrounding the magnet whereby its influence can be felt, okay, where its attraction or its repulsion can be felt, okay, by an object which is kept nearby, that will be called as magnetic field. And the field exists in the form of lines. So after careful observation and study, okay, scientists have concluded that the field, okay, exists in the form of lines and is known as magnetic field lines. So we'll discuss more on this. So let us study how the field is studied. So how is it studied? How is it studied? Let us learn how the field is studied. So the field is studied, so it is studied magnetic. So magnetic field, magnetic. Magnetic field is studied by drawing imaginary lines called it should be imaginary lines called magnetic lines of force. So how do we study the magnetic field lines? Magnetic field is studied by drawing imaginary lines called magnetic lines of force. So what are these magnetic lines of force? Let us draw a magnet and let's study. Okay, let me show you the magnetic lines of force. So first of all, we draw a magnet. Okay, let's say this is the north and this is the south. So these magnetic lines of force, they emerge from the northern end. Okay, they emerge from the northern end and then they enter the southern end. So they emerge from the northern end and then they travel all the way to the southern end. So they always emerge from the northern end and they travel to the southern end. Okay, they emerge from the north and they travel the south. Okay, inside also they'll travel. Okay, inside also they'll travel. Okay, inside they'll travel from south to north. Okay, then again it will appear. Okay, they emerge from the north and then they enter the south. They emerge from the north and they enter the south. Okay, like this, like this, like this. Then they emerge from the north. So always start the arrow from the north because they emerge from the north and then they head towards the south. Okay, this is how it is drawn. Okay, this is how magnetic field lines of force are drawn. Okay, so in a given magnet, this is how, okay, the magnetic field lines exist. They exist in the form of lines. Okay, and this has been, okay, experimented and has been verified. Okay, this has been experimented and verified. So in your textbook there is a demonstration about, let's say I have here the exam board, and this wooden piece of, this is a wood only, so this is not wooden piece of wood, this is actually wood only. Okay, so a cardboard, and let's say this is a magnet. Then on this cardboard we will place iron filings, okay, iron fillings, which are crushed powders of iron. Why are we using iron? Because iron, okay, is attracted by magnet. Then we place a magnet here, and then what we do is we tap the cardboard like this. Okay, we tap the cardboard. On tapping the cardboard, the iron filings, they jump, and then when they jump, okay, they realign it themselves again. They realign themselves to the attraction which is produced by the magnet here placed in the middle. So after, okay, tapping, okay, after tapping and after demonstrating this, after doing this, okay, they found that a particular arrangement was observed. Okay, this arrangement existed in the form of lines. So on close observation they found that, okay, it displayed the pattern of lines. Okay, so that is how we concluded that the magnetic field lines, it exists in the form of lines. Okay, so magnetic field lines does not exist in the form of any other shape, but it exists in the form of lines. So now we will study the properties of magnetic field lines. So let me erase this, and we will study the properties of magnetic field lines. Now, properties of magnetic field lines. So let us study the properties of magnetic field lines. Magnetic field lines. The first property that we will be studying is, now, they always originate from North Pole and terminate at South Pole. Magnetic field lines, they always originate from North Pole and terminate at South Pole. Let us draw a figure for this one. So let us say this is the figure. Let this be the north and let this be the south. Let me draw the magnetic field lines, remembering this point that they always originate from the North Pole. So the magnetic field lines will originate from the North Pole. So this is the North Pole. Okay, let's do like this. So this is the North Pole. So we can draw like this. 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 Now, as you can see, they all originated from the North Pole. So originate is from here, they origin from here, they origin from here, they origin from here, they origin from here, and they travel to the South Pole. They travel to the South Pole. So they travel to the South Pole. Then again from here also there will be, again from here also there will be, then from here also there will be, from here also there will be, then from here also there will be, and from here also there will be. So this is how the magnetic field lines will be, all originating from the north and entering towards the south, all originating from the north and entering towards the south. So remember this, that they always originate from North Pole and terminate at South Pole. Point number 2, field lines field lines are always ALWAYS. I am very confused with the spelling of always. 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 Field lines are always closed curve. CLOSED. Close curves. Now, field lines are always closed curves. Now, okay, before that, okay, complementing point number 1, they always originate from North Pole and terminate at South Pole. Now, inside I have not drawn, but remember, my dear students, inside how the magnetic field lines will go, they will run from south to north. They will run from south to north. They will run from south to north. And remember that no two magnetic lines of force, no two magnetic field lines, they intersect. That means they should not touch. They should all be parallel. Here I have tried my best not to overlap them or to intersect them, because magnetic field lines, they don't intersect. Okay, they never intersect. Intersecting means like this, okay, touching each other. They don't do. They will only travel parallel to each other. Okay, they will never intersect. They may be close curve, but they will never intersect each other. So here you can see inside the magnet, inside the bar magnet, the magnetic field lines, okay, they are traveling from south to north, whereas outside they travel from north to south. Outside we are talking about this. We are talking about these curves. They travel from north to south. They emerge from north and then they enter the south. Whereas inside the magnet, look at inside the magnet, we are talking about this. See these lines. We are talking about these lines. These lines which are parallel with each other, and then where are they heading? This is the southern end, and they are moving towards the northern end. Okay, so you have to remember, outside the magnetic field lines, they move from north to south, but inside the magnetic field lines, they move from south to north. All right. And the second point, field lines are always closed curve. Look at any of the curve. Okay, they are all closed. If you consider this one, look at this. This is the curve, and then it ends here, and then see this is closed. It's not open. Okay, or you can look at any one. If you consider this one also, look at this one. From inside it goes all the way here, and then again it climbs up here, and then it continues its curve and it touches here again. So they are all closed curve. That means they are all like this. Okay, they are all closed curve. They are not open. If it were open, it will be somewhat like this. Somewhere, okay, the curves will stop. So they are never like this. Rather they are like this. Okay, so they are all closed curves. Okay, then point number 3. What is point number 3? Field lines are crowded near the poles. No doubt, field lines are crowded near the poles, which shows the strength of the magnet. The first part of the answer reads, field lines are crowded near the poles. These are the poles, my dear students. These are the poles. Look at this. Look at this area. These are the poles. It is very clear that the field lines are crowded, isn't it? Look at this area. Okay. Look at this area. Okay, and compare this area. Look at this area and compare this area. Field lines are more here, and these are the poles. Okay, so field lines are crowded near the poles. Okay, and then the second part reads, which shows the strength of the magnet. What does it mean? Okay, let me just give you a simple example. Let's take two poles. Okay, let's say this is the north. Okay, and then let's say here one magnetic field line, two like this. Okay, then let's take another one, same north. Okay, but this time one, let me make some more. Okay, now you see, look at this and look at this. Okay, this is A and this is B. In which pole, okay, do you see more magnetic field lines? In A or B? You will find that in the north pole of B, you will find more magnetic field lines. Okay, So if more magnetic field lines, that means the magnet is stronger here. This is a stronger magnet. So stronger magnet. This is a stronger magnet. How? Because the magnetic field lines are more, which makes the magnet stronger. Reason stronger magnet. Reason is because of more magnetic field lines. Because there are more magnetic field lines on this pole than in this pole. In this pole, we have only a handful. Here, we have more. So, having more magnetic field lines, this North Pole is much stronger, making this magnet stronger than this. Okay? So, this is point number 3. Now, the last point number 4. Field lines never cross each other. Field lines never cross each other. Never cross each other. Or in the bracket you can write they never intersect. Field lines never intersect. Okay, this is the other. This is what it means. Field lines never cross each other, or field lines never intersect. What is the meaning of this? It means to say that, okay, now you see, if two field lines intersect, what will happen? So you see this one, and let's see this one. So this is one field line, magnetic field, and this is another magnetic field. Okay, and they are intersecting. So at this point of intersection, look at this point. Okay, this point has got two directions. One direction is this one, and the other direction is this one. Now, is it possible that a given body can travel in two directions? Imagine I am the body. Is it possible for me to move in two directions in one go? Can I go here and can I go here? No, is it not? I cannot do that. I cannot go here and I cannot go here at the same time. This is impossible. In the same way, okay, this particle, this point cannot go in two ways. Cannot go here and cannot go here also. Okay, since this is impossible, okay, so this is impossible. So since this is impossible, two magnetic field lines can never intersect, because if they intersect, then this will arise, and this is impossible. This is impossible. So if two magnetic field lines intersect each other, then at the point of intersection, this case will arise. So just like I myself cannot go to two places at one time, this point, okay, cannot have two directions. Because of this reason, field lines never cross each other, field lines never intersect. So, okay, so the reason, if you want to write the reason, I'll give you the reason. Two directions of magnetic field cannot exist simultaneously. Two directions of magnetic field line cannot exist simultaneously. Two directions of magnetic field line cannot exist simultaneously, so magnetic field lines do not intersect. So magnetic field lines do not intersect. So this is the answer to this. Okay, so we have come to the end of the video, so I'll be ending the video from here. But before I go, I have a small question which I want all of you to participate and answer. It is based on the discussion that we have discussed. So the question for you today is, if a magnet is broken into 5 parts, how many north poles will be there? Answer you give me in the comment box. So you kindly comment the answer in the comment box. So this is it, my dear students. Thank you all for tuning in and watching this video. Like I said, this is the first video and this has been the introduction only. In the next video, we will be going deeper into the lesson. So stay updated, stay tuned and keep watching, and I'll see you in the next video. Until then, you all take good care and God bless you all.